Welcome to the Building Savvy Bottom Line. I'm your host, Beverly Smyrnas. Our bottom line goal is to ensure that building or remodeling a home is a seamless and enjoyable process, helping builders and their customers better understand each other's challenges, expectations, and industry norms. This episode is brought to you by The Ultimate Guide to Buying and Building in Texas, an online course for Texas newbies or anyone making their first home purchase in Texas. To learn more, visit buildingsavvy.com. Hi there. I'd like to welcome Armando Cobo to the studio today. Armando is a residential designer and he designs ZeroEnergy ready homes. And he's also an instructor of the ZeroEnergy Ready Home program for the Department of Energy. And so Armando is very passionate about building houses to perform to the highest of expectations. So Armando, tell us a little bit more about yourself.
Thank you. Yeah, I've been on this ride for about 40 years. After I got out of school, I studied architecture and management, and I worked for a developer, and that was in the mid-'80s, back when it was fun to do projects with savings and loans, and then the RTC got over and kind of shut us down, so I went through that experience, and then after that, I decided to go on my own, building homes, mostly custom homes in the Midwest. So I would design them and then build them also. Soon after that, builders start asking me to design houses for them. So that seemed like a natural movement there. About 27 years ago, I had a bad accident. I fell off a 2-story roof and broke a bunch of bones and shut me down for a year and a half with a lot of pains and aches. But then after that, I moved to New Mexico, and it was about the time where the green building movement was just starting in the country. Austin had started their green building program and they were going pretty strong. In New Mexico, we used a lot their assistance in creating our green building program in New Mexico. And about that time, Colorado and Arizona and different places in the country. And I think it was in the about 24, 25 years ago, a whole bunch of us around the country met in Portland, Oregon. There was about 100 of us, and we decided to take all the green building guidelines from the people in Austin, New Mexico, Colorado, California, Minnesota, and everybody was doing their own thing. And we decided, why don't we put together all these guidelines and make it one central set for everybody to use? And so people in Minnesota or people in Miami or New York or Phoenix, they could use those guidelines and adapt it to their climate zone, the things that they could do. At the time, the USGBC offered to sponsor that, and it became the Lead Age program. And about a year or two later, NHB decided they wanted to do the same thing. So many of us that were members of the USGBC and also NHB decided to help with the NHB Green program at the time. Later on in years, it became the standard. And then the Lead Age program became the Lead for Homes program. So about 14 years ago, DOE started it kind of took on improvement from the Energy Star program for homes that it was created in the mid-'90s or late '90s. They decided to develop the Building America program, but the Building America program was just guidelines. It was not really a program. But then DOE decided, let's just take that and do the ZeroEnergy Ready Home programs, which is basically building the house to high standards. So if the client wants to have renewables later on, we could do that. Remember 14 years ago and past, the cost of solar panels was pretty high. It was an option. But at least if you could build the house that it was as efficient as possible with super tight building envelope, and using all Energy Star's lighting and appliances and plumbing systems and so forth, by the time somebody used renewables, it would be beneficial. Today, the Zero Energy Ready program kind of requires a home to have a Hertz score in the 40s. So it's typically mid 40s to high 40s. Most of the houses that I design are around 40. So that means that is 60% more energy efficient based on the base standard of 2006 Energy Code. And so since then, the program has lowered the Hertz score and now is in the 40s. And so that's what we do. I would say about a fourth or a fifth of the homeowners go ahead and install solar panels or solar tile, solar roofs. Then most of those houses are somewhere between a Hertz 10 and a Hertz minus 10. We're doing a house now that is minus 43. And the reason for that is because they wanted to install 4 car chargers. And each car charger requires a lot of, solar stuff. So that house will way overproduce their energy needs. But, that's what the homeowner wanted.
So the Zero Energy Ready home, it just equips the home for the people that eventually buy the home to add whatever they want to get to zero energy. Is that right?
That is correct. So we typically install all the conduits and the house is ready with a switch up in the attic or in the garage or whatever the switch is installed, that all you have to do is just plug the panels, or I've done few houses where they have wind renewable. A couple of them also, they use ponds. And so there's different ways to achieve the zero energy renewable side, but it's all plug and play. That's it. So have the house ready, build a good envelope and as efficient as you can. And from then on, it's just plug and play.
Well, let's talk a little bit about backing up a little bit. Besides the readiness to be connected to the renewable energy resources, I know in some of the classes that you've taught to our builder audience, there's also a lot of framing and sheathing and structural things that you do to prepare the house to perform at this level.
So typically what I tell my clients, the homeowner and the builder, is that I want to solve all the problems or as many problems as I can in the design stage. So we're not stopping the construction because somebody messed up on the framing or whatever. So I come up with plans that are fully detailed and specified. I work with the truss company deciding where we're going to have all the chases for the duct systems or whatever, or if we happen to do an attic truss or whatever, where is it going to be located? So I want to have those situations solved. The headers for every single window and door is already specified on the plans. So the framer, all he has to do is just read how long, what type, and they're all right size headers. So the old system was that we used 2x12 for all, double 2x12 for all the windows. It didn't matter what class it was. Well, nowadays we know that using the tables that are in the code book, we can have windows that are just with 2x4, double 2x4s, and the same window used on the first floor, but having 2 floors up above. Now, the same size of window, we'll have to probably use a 2x10 because why? We have more weight, more stuff up above it. So we really need to solve a lot of the issues ahead of time, where the plumbing is going to go, where the HVAC system is going to go. Putting HVAC systems in ventilated attics is just the dumbest idea because, as we know, down here in the South, especially, our attics, their temperatures in the summertime are somewhere between 150 and 180 degrees. And so it just makes no sense to have HVAC equipment and duct system in a ventilated attic. So how we're going to do that? Okay, so we're going to put them inside. Well, we're going to have a mechanical room or we're going to have mechanical closets. How are we going to run the ductwork? Do we have plenty of a space to run 8-inch ducts or 6-inch ducts or 4-inch ducts? Is it going to be high velocity or is it going to be what? Are we going to use heat pumps or what? And so a lot of the things that I see people asking in in national forums like Fine Home Building Magazine or Green Building Advisor or whatever, I just scratch my head because these are people already building houses and they're just barely getting to decide what systems we're going to use or how we solve these problems. I want to do that in the design stage.
Absolutely. And I know that part of designing the shell of the house is the various layers that you use to make the house completely airtight and moisture proof.
So that solves about 90% of the problems that we have in homes today. Moisture management and a tight building envelope. And so we need to decide what type of wall assembly we're going to have. Do we want the wall assembly to dry to the inside, or do we want it to dry to the outside, or we want it both ways? The idea that a house needs to breathe is just, houses don't breathe. Only people and animals breathe. We need to ventilate and dry the house out. And so that's how we have to decide what materials we use on the wall assembly and the roof assembly and our foundations. And so not all really good materials are the right materials for the right application. So we need to figure out that, for example, there are certain types of rigid foams that I do on the outside of the wall, or we may do it on, above the roof sheeting, that some of the rigid foams are not the best materials to put in there. Some of them are. Some of the insulations that we put inside the house are not the right insulation to put on the house. There's a lot of builders that think that foam is a cure-all for everything. Just foam it. And no, you can actually create more problems by using foams if you don't do it in the right application. So those are the things that we need to learn to do. Permeability analysis. We need to do dew point analysis. We need to figure out what type of insulation and how much of that insulation we need to use to make sure that if there are condensation issues, we need to avoid that. We need to avoid moisture issues, all that kind of stuff. We need to put details on how to install windows correctly. We need to put details and specifications on how to protect the house from moisture. That right there is about 95% of the problems in most houses. And it's not about the products, it's about the applications and the installations.
Yes. I know that some of the green building techniques have actually helped builders to use less lumber, and they actually not only save trees, but you save money on using less pieces of wood.
Well, there are several builders, especially production builders, that have systems pat down for building hundreds of homes at the same time. Well, those guys are used to save somewhere between 20 and 25% of the lumber that we used to do 30 years ago. And so by using advanced framing techniques. Now, in a lot of the big custom homes that I do, obviously we can do the typical savings as a basic 1,500 square foot house. A typical custom homes has much taller walls, and we have to have beefier walls, and it's got bigger windows and bigger door systems and so forth. So now we have to increase that. We typically can save easily 15% of the lumber package just if we know how to design properly. At the end of the day, I want for my clients to have the most efficient house at the most effective cost. Because of that, we can see throughout the United States, there's tens of thousands of homes now that have been built under the ZeroEnergy Ready Home program, where the cost of building one of these homes is between 1 and 3%. And that is based on the average home in America, which is between 2,000 and 2,500 square feet. Obviously, some of the homes that I design that are 10, 15,000, 20,000 square feet, these folks are using materials and products that are way above what most people would think. Like, for example, we're finishing a house that has about a 15,000 square foot house, and it's all Tesla roof tiles. Well, that's $500,000 just, Tesla roof tiles. So you can't figure that this type of house is going to be just 1 to 3%. They're much more. But a typical 1,500 to 2,500 square foot house, you can easily afford it if you know what you do. And if you design the house correctly, you're somewhere around 1% in the South, about 3% up in the North, just because they have to spend more money protecting the house from the weather.
Just to clarify, you're talking about like 1% more than you would spend if you weren't taking some of these extra measures.
That is correct. So if you're building a house that is $200,000, regular house, and then I'm going to design and build one right next door, design them properly and building it properly with the right information and the right things, we're just going to spend $202,000 if we're in the South, and maybe $206,000 if we're in the North. So it really is not that much money. You just need to know how to design it properly and how to buy and use the right products at the right application.
And then you have return coming fairly quickly on that kind of an upgrade investment in the savings from utility bills, correct?
And it's kind of interesting because a lot of us that have been working in high performance houses, we do energy analysis and economic analysis of all these houses, just because it's on everybody's interest. And we know that we can recuperate that 1 to 3% extra in 3 years or less. The most important thing is that typically these homes have much higher comfort level. That is something that you cannot put money on it. Also, they're healthy homes because their HVAC systems are designed properly. Most houses I design, we install 1 ton of heating and cooling for 1,200 to 1,500 square feet. That is designing them properly with the proper duct design and the proper registers and so forth, and the proper ventilation, humidification, or dehumidification, depending on what climate zone you're in. And in some cases, you have to do both. I'm doing a house in Ann Arbor, Michigan, where, yes, we're going to need dehumidification in the summer and in the shoulder seasons, but in the wintertime, we're going to have humidification. So those are the things that you have to take in consideration where you're building a house, what is the climate zone, and sometimes it's dry, sometimes it's wet, sometimes it's both. And so you have to take a chance of that and apply the right products for the right application. Again, and I cannot overstress that because most people get comfortable using the same products for every single house in whatever climate zone. And well, it may be the right decision, but it may not be.
Right. I know that the knowledge and the education is becoming more mainstream, but it used to be, I remember not that long ago that a lot of builders made the mistake of thinking, well, I'll just put in a bigger air conditioner, thinking, oh, that'll make it all nice and cool because my clients really like to keep their thermostat at 65, but that's not the right answer. We know now.
I don't think so, but of course, there's an education process that is not only with the builder, but with also the client, the homeowner.
Wow.
And fortunately, I've been able to develop PowerPoint presentations, for example, that I introduce to my clients, the homeowner. And I always tell them that by the time we design the house and build it, they'll be just as much as an expert in building science as I could be, because they know that they have to run their house properly. And they know that the mechanical system is designed for a certain temperature. And we try to tell folks, that, if you want to run the air conditioning at 65 degrees in the summertime, and your kids are running in and out, leaving the doors open because they have a swimming pool and all their buddies are playing around and so forth, that house is not going to stay cool. I don't care what you say or what we do on that house. It's just not going to happen. But in typical usage, having an oversized HVAC equipment, actually it works against the house because the system short cycles. And when the system short cycle, then it shuts down because it says, oh, okay, I just cooled the house to 68. And so now I can shut down, but it only took 5 or 10 minutes to run it. Well, the problem is that most HVAC systems, especially, in the heating and cooling stages, they need to remove humidity. And if the system shuts down and it does not run for at least 20 to 30 minutes, it's not going to remove humidity from the house. So what happens is that now you have high humidity in a house. That humidity with the temperature of the air moves up as it gets higher. It gets into the attic, and then it can create problems. If it's a conditioned attic, it can create problems. If you don't have the right dehumidification or ventilation system, it could be on the walls. Many times, especially here in Texas, I go to a friend's house and it's the middle of the summer, and their windows are condensing. I'm just thinking, let's just think about if your window is condensing, it's because you got too much humidity inside the house. You're running your air conditioning too cold, it's too hot on the outside, it's condensing. If it's condensing on the window, do you think it's condensing also on the walls? And so how often, especially remodelers, they know that every time they remodel a house and they try to get drywall out of an existing house on an exterior wall, usually that insulation is black. And what is that? That is mold. And so that also creates health issues for the folks living in the house. And most people don't see it until it comes outside of the drywall, which that doesn't always happen, but that's another part of the equation that people don't realize how much people spend in health-related issues. Several years ago, I believe it was the it was one of those national organizations about health, where they said that most American families spend about $120 per month per family on health-related issues because our homes doesn't have good and proper indoor air quality.
Wow. I've known Armando many years now, and I know every year there seems to be more information about how to build houses more efficiently, how to make them perform better, how to make them healthier. So I think the old thought that, an old house was a better house we've proven that's not true now. And I think, to the person building a house, having a designer who understands the whole science behind it and what combination is the right combination of products to build the healthiest house and the best performing house is key.
Well, and it's just amazing to me that very often I get builders or subcontractors saying, well, I've been doing it this way for 30 years. And so unfortunately, my answer is, well, you've been doing it wrong for 30 years. The idea that things don't change or have not changed in building houses, I don't understand why people are not receptive to those ideas. Our vehicles are better today than they were 30 years ago. I mean, we got computers we didn't have 30 years ago. I remember my first computer was in 91. I think my watch today has more power than that computer 30 some years ago, and so if things get better, our appliances are better, our cars, even our glasses are better today, our TVs. Think about the TV that you have now versus the TV that you had 30 or 40 years ago. So if everything improves, why is it that some people have a hard time understanding that houses are the same? They also improve. We have improved, believe me. I was a builder 40 years ago, and I have nightmares thinking about those houses I built back in those days compared to what we build today. I just don't get it. People that are so reluctant to educate themselves. Today, there's free education everywhere, online and webinars from product manufacturers, from people in the industry like myself, like you guys at Building Savvy that produce a lot of content online and magazines and also in educational shows. So there's a lot of free stuff, and yet people don't take advantage of that. And that is just sad, because if one of our family members need to have a surgery, we look for the doctor that has 100 diplomas in that wall, right? And the fancier the university, the better, okay? Because we think he's a better doctor, okay? Same thing with our attorney. We would never think about hiring an attorney or an accountant or somebody, that doesn't have continuing education and all those. Why can't we do the same thing for the guys that build our houses?
Right.
Couple of things that I can tell you. I mean, people know that we have a tax credit, the Inflation Reduction Act, a couple of years ago in 2022, extended the 30% tax credit for renewable energies for the next 10 years to the year 2032. It goes 30% until 2032. It goes to 26% in 2033, and it goes to 22% in 2034. Having said that, we just assume that if we still need that, maybe Congress will extend that. So there's plenty of tax credits with that. There's also the IRS has the residential tax credit, the 45L, for builders who want to build to either the Energy Star or the Zero Energy Ready program. And that is applied to single family, manufacturer housing, or multifamily. So there are plenty of advantages for builders and homeowners to take advantages of all this tax credits and make the house more affordable. Here's the clicker. If I'm going to spend 1 to 3% more building a house, a regular house, the typical Zero Energy program house, it is getting somewhere around 9 to 10% more appraised value. So if it costs me 1% more down here in the South to build a house, but I get 9 to 10% more, I'm leaving money on the table if I don't apply this tax credits and all these things. I mean, so I can increase my value on my house by a net 7 or 8% extra. To me, it just makes sense economically just to go that route.
Absolutely. And it is that combination of material choices that truly create the performance element of it. I wanted to touch on that. So a lot of times you'll see a product advertised as having an R value, but it's really in the way it's installed and what it's installed beside that determines the ultimate performance value of that one particular product. It's really the way the whole selection of products that you specify work together. Is that right?
Yeah, sure. Let's say, for example, if I have a wall assembly that I want to use 1 inch of rigid foam on the outside. If I use polyiso down here in the South, I could have an R6.7 or an R7 value to that polyiso. But if I'm going to use that same insulation in Michigan, I can only count as an R5. Why? Because in cold climates, polyiso loses some of the R value. Also, for example, if I use a reflective sheeting on the roof decking, I better have at least 2-inch space between that reflective sheeting and any type of insulation if I'm going to use a condition attic. Or otherwise, that I hear some people installing, some of that reflective sheeting on the roof, and then they'll go ahead and install open cell foam against the roof decking. Well, that neglects completely that reflective R value of that product. And so, yes, not all products is the right product for the right application. So you really have to do your homework. It's smart to learn how to do a dew point analysis and a permeability analysis. If you want to know which way your roof and wall assemblies are drying out to, make sure that you don't produce or you don't help the idea that some condensation can create moisture problems in the long run. So, and of course, there's folks that think that foam is the cure-all. It is not. Another product, for example, Huber Zipboard. It's great board. It's a great product, and it has a moisture barrier attached to it. But part of that is that you have to install the tape correctly. You're supposed to wipe clean the sheathing before you put the tape. You're supposed to put the tape in a shingle manner and use the roller because it has an adhesive that it becomes active when you roll it. But if you don't do those things, that tape is going to peel off and moisture is going to go through there. And so there you go. You spend a bunch of more money on a really good product, but if you don't install it correctly, it's going to fail.
Armando, what is on the consumer side of things? Like, how do you know if it's being installed correctly? Like, if I'm your client, I'm working with you, are you going to go out there and look at and evaluate it, or how does it?
Well, there's a couple of things. At first, I like to have a meeting with the builder and the critical subcontractors. If I'm here in town, it's really easy to do. If I'm out of state, either the client can pay me to go there or we can do it through Zoom. Fortunately, that's one of the advantages of technology today, that I can hold class on a Zoom and we can have 6, 8 critical contractors and subcontractors on a Zoom presentation, and we'll go over the plans for that house. We'll go over all the materials. At that point, the plumber, the electrician, the framer, somebody can say, hey, I have a question, and we solve it in front of everybody. It doesn't mean that I'm 100% have the best solution. Maybe somebody else has a better solution than what I have on the plans. And so we'll discuss it. And there's been a few times that we changed the specifications because somebody thought that their system or their product was better. And so that is the reason to have this meeting before we start building the house. Once the house starts building again, if it happens to be here local, I go to the job sites, I verify it, I help the builder. Now, there's some builders that after so many houses, they feel comfortable doing it themselves, or, there's been a builder or two that didn't want my help at all. But for the most part, I like to make sure that the clients get what they're getting paid for. And I've been doing high performance houses now for almost 25 years. I'm glad to say that I haven't failed once yet. So knock on wood, so far my clients are really happy with the work we do for them. And most of the houses, we got 5,000 square foot houses spending $125 to $150 a month in energy bills. I mean,
compared to the neighbors who would be spending $500, right?
Exactly. So it's just said, actually, not long ago, I went to a house in North Dallas. It's a 6,000 square foot house, and they're spending $2,000 a month in energy bills.
Wow.
The house must have awful insulation or, infiltration problems. I don't know how is it that they're spending $2,000 a month in energy bills. Maybe they turn the lights on all day long. I have no idea. 20 TVs and who knows what, the swimming pool and whatever. But I mean, to me, that's ridiculous. And so, I mean, all I can compare is a house that we did also in Dallas that is 6,600 square feet. And they have a swimming pool. And this house, they spend less than $200 a month in energy bills.
Yeah, it's really something to think about when you think about your monthly spend,
Yeah.
whether or not finance that extra one to even a little bit more up front into your mortgage to pay for some of these things that are going to offset that.
And actually, many years ago, Fannie Mae, Freddie Mac, they developed the energy efficient mortgage loans, which most realtors, most bankers, most builders don't know about. And that allows you, there's different qualifications, but that allows you to use that monthly saving into the mortgage payment. So you can qualify for a bigger loan amount just because your house is energy efficient. Insurances. Look at what's happening in Florida and in the Gulf Coast and all that. Insurance companies are not insuring houses because they're not being correctly billed. And they do it year after year after year. So believe me, the economic side of building a high performance house is not more than just the cost of the house. It's the cost of maintaining, repairing, and living in the house.
Let's talk a little bit about that resilience factor too, that a zero energy house is also more resilient to the crazy weather patterns that we see in our world today.
Exactly. I mean, as we well know, here in North Texas, we have tornadoes. And one of the things that I do, for example, the houses that I'm designing right now, I got 3 houses being designed in Houston. We're using Cat 2 and Cat 3 level of resiliency. So what happens is we have to make sure that at least it's going to cover to about 90% or 95% of all hurricanes. Same thing here in Texas and the house that I'm doing in Oklahoma. I'm designing those houses to EF2s. One has to an EF3. That's what the homeowner wants. How much do we spend? Sometimes less than 1%. There is a client, actually, they never became a client because they thought that designing their house as a zero energy with resiliency in mind, they just didn't see that as a good thing. Unfortunately, a year ago, Salina had a tornado that went through, and one of the builders called me and he says, "You remember so-and-so client?" And I said, "Yeah." And he says, "Their house got blown away by a tornado." I felt awful, but you know what? They had the chance to design their house properly. Now, it wouldn't have meant that their house didn't get blown out, but the tornado that went through Salina was an EF2 or an EF3. And so more than likely, their house would have survived better or maybe had no problems at all. But it's unfortunately that people are not thinking ahead, that just spending an extra 1% more on resiliency, it can save them from their house being tore up, you know. And so, but they don't mind spending $30,000 or $50,000 on a fancy stove in that kitchen, or $30,000 or $50,000 on an entry door system because it looks pretty. But yet, when it comes to making the house resilient and energy efficient, a lot of people have problems.
So we talk a lot in this course about the minimum standards, which are the building codes, and there's inspectors that come out and make sure that you met those minimum building codes. But Armando is talking about spending a little bit more to have a house that really is adaptable to what could come your way as far as storms and certainly just everyday comfort. With the Zero Energy Home program, in order to be rated as a zero energy ready home, you have special inspection processes that verify certain criteria have been met.
So what we need to do when you're in the Zero Energy Ready Home program, we have to hire a HERS rater. These are people, they're affiliated to a national organization, it's called ResNet, and they educate and train people not only to verify construction of the house. They usually has 2 or 3 steps where they go to the job site and verify the processes that we're doing. But even before they start the construction, they'll do an energy analysis to make sure that we're installing the proper equipment and the proper wall assemblies and roof assemblies and so forth. Unfortunately, when we talk about codes, code is the minimum, the minimum level of efficiency and structural and fire and everything that you can put on a house. Let me just give you this. If you're flying across the Atlantic and the pilot comes and says, "Oh, by the way, this plane was just built to the minimum code for planes," how comfortable would you be? Okay. And I think Boeing is going through that process right now. Well, it's the same thing on a house. I don't know how many times I can tell you, I talked to a builder and he goes, "Oh, we built to code." Big whoop. Okay. That is the minimum legal house you can build. And unfortunately, in many municipalities, the building code officials are not up to date because their cities don't have the money to educate them every year. And so they're not up to date to the latest of everything. And in fact, in Texas in general, we don't have the highest standard of construction. And a lot of it is because building codes allow builders to do things that are not really the right thing to do. But as I complained to the city of Dallas many years ago, and their answer to the head building official was, if we stop every builder from building their houses the way that they're doing, pretty soon we have no houses being built, and that's a tax revenue that the city loses. So there you go, okay? So if you're going to think that the city building official is going to make sure that your house is built properly, think again. Okay. Having a third party verifier like a Hearth Rater, it improves your chances. Having a designer or an architect that knows what to do correctly and goes to the job site and teaches people how to do it correctly, that's another benefit to you. So unfortunately, we're just getting to the point that now building houses the way the code is demanding now that we build houses to a minimum is getting to a point that if you don't do it right, you create more problems that you intended to solve. So doing it the right way from the start is a benefit to the homeowner, to the builder. Many years ago, the National Home Builders Association did a study of a multiplier that for every dollar you spend installing a product, it costs $10 to repair it, and it costs 10 times 10 if you're in a lawsuit. So it's a multiplier of 10. For every dollar, you could spend either 10 or $100 fixing problems.
Yeah. Let's talk just briefly what some people might not know about the differences in the Texas climate specifically. Thinking of those consumers that are taking this course that are not as familiar with the challenges that we face in Texas because of climate.
Well, the Department of Energy has a climate zone map that anybody can access through Google and whatever. Most middle and southern Texas is climate zone 2. Unfortunately, from my point of view, Dallas County and Tarrant County in the 2021 code was downgraded from climate zone 3 to climate zone 2, which it means that now less insulation is installed in houses on climate zone 2 in Dallas County and Tarrant County. Yet the counties to the east and to the west and just barely north, Collin County, which is Frisco. If you're going to tell me that Frisco is climate zone 3, but Dallas or Plano is climate zone 2, it's insane. From my point of view, when I design houses in the Metroplex, I still think that it's climate zone 3. I'd rather be overcautious and overprotecting my clients than them having to have problems. And unfortunately, a lot of these code changes are made because the international code canceled things that is better for a house to build that way. But unfortunately, the trade associations for building homes and building commercial buildings, they're always pressuring the code officials to weakening the code. That is a fight that has been going on for years. And from my point of view, I just rather build a house for my client the same way I would build it for myself, which that means I'm going to take care of the energy efficient and the good indoor air quality, good healthy house, as well as resilient. I also include universal design because as we well know, we're aging. They're expecting that we're going to add an additional 50% of people between 60 and 80 years old within the next 20 years. And so we're getting older. Our parents are coming to live with us in many instances. I happened to have a major accident 27 years ago. I wasn't even 40 years old. The house that I live in, it wasn't as comfortable for me with, all kinds of surgeries and things like that. So you never know when you really need to have a house designed for accessibility in case you need it.
Yes, and that particular area of construction has come such a long way. It's not like you would even notice that a house is built with that in mind. It's just got a little bit wider doorways and hallways and just some zero threshold showers and stuff like that. They'll look great, and you would never know it's because you're also considering the universal design aspect of it as well.
Exactly. And so it doesn't cost that much more.
Right.
What's the difference? I mean, you look in typical houses, you have 30-inch doors. Well, how much is a 30-inch door versus a 36-inch door? It's not that much money. How much is it? Yeah, designing a 3-foot hallway, it's hard to move furniture and things, let alone somebody in a wheelchair or a walker. So why not design a 4-foot hallway? Right. And if you got bigger houses, of course, you can do it bigger, but always try to, even on a 2-story house, it's always a good idea to have the primary bedroom on the first floor. Always think about if you have somebody that needs accessibility, make sure that you have it on a 2-story house, make sure that you do a stairway that is 4 foot wide in case you need to have a sit-on-track railing. There's all kinds of options that you can do on houses for someone who needs an accessibility. And it's not just about wheelchairs and walkers. It could be sight or hearing. There's different things that you can do for those folks. As you know, when I'm working with a client, I'm always asking them about the health of the family and the health of their parents or somebody who may need to come and live with them, because that is just a very common occurrence.
Correct. Well, I think bottom line, what Armando has to tell us and teach us today is that think about the aspects of your home and not just upgrading that countertop to the most expensive option, but putting some extra thought and effort into the front end design of the house, thinking about how you're going to live in it and how putting in that little bit of extra to make it comfortable and healthy and resilient and all of those things. So important. You can always upgrade that countertop later and you can't redo the walls later, right?
And here's the thing, that if you don't take care of the primary things of the house, a foundation, fixing a foundation is expensive. Yeah. Fixing a wall assembly and a roof assembly is expensive. If you don't do it right, that can create problems of indoor air quality and health issues for your family. Those are things that you have to take care of it up front, okay? If you have to sell your house within 7 years, it's always known in real estate, you sell a home in less than 10 years, you're losing money because you have to spend cost of mortgages, cost of buying a house, real estate fees, all that kind of stuff. Less than 7 years, you're losing money. If something happens to you or your family and you have to move because an issue and you didn't take care of it in the design, that's going to cost you money. Mm-hmm. I just talked to a client about their forever home. They're both in their 60s something. The guy just retired. The lady's going to retire in 2-3 years. And I said, you need to think whether this house is going to be your last house in the next 20 years, or if it is a house that you're going to be forced to move in 7 years, because maybe in 7 years you have mobility issues. So what do you want to do now? And so those are the things that, as the professional of designing a home, I have to get personal with my clients. And that may be uncomfortable questions and answers to give, but those are things that if I'm trying to do my best for them, why? Because I've already lived it, and I have plenty of clients that have already lived those situations.
Right. Okay, well, Armando, I just want to thank you so much for all the great information you gave. Lots of food for thought here. And I hope that our audience has learned a lot about what needs to go into their thought process as they begin to design the home.
Well, thank you. Thanks for the opportunity to talk to you guys. The main thing that I want anybody listening to this podcast is that buying a house is not about trying to buy the biggest house for the least amount of money. Put a thought to it. It's not like buying a bottle of wine or a set of golf clubs, okay? It's the largest investment you'll ever make in your lifetime for most of us. And so put some thought on really how efficient, how much the health of your family, how much the mobility issues is within you and your family, and what do you think it could happen in the next 10 or 20 years? And I know it's not a perfect solution, but designing a house properly to at least make it more accessible at this point and more resilient, it will save you money in the long run if it's not just with the energy efficiency.
Thank you very much for all your great information, Armando. We really appreciate you being on our show.
Okay. Thank you so much. Have a good day.